Okay, this is how to draw the Lewis structure of SF6, sulfur hexafluoride. First thing we have to do, count up the number of valence electrons. So the sulfur has 6, and each of these 6 fluorines has 7, so that gives us 6 sevens of 42 plus 6, altogether that's 48 valence electrons. Okay, so now we have to connect these atoms together using single bonds, and the electronegative atoms tend to be on the periphery, so it makes the most sense to put the sulfur in the middle and surround it by all 6 fluorine atoms like this. Okay, so now we've used 2, 4, 6, 8, 10, 12. We've used 12 electrons so far to create this structure, so that means we've got 36 more valence electrons to add to this structure as lone pairs. So we're going to start with the electronegative atoms, so we can put 3 lone pairs on each of these fluorines, and if we do that, that will add up to altogether 48 valence electrons. Okay, so now if you count up all those single bonds and lone pairs, we've altogether used up 48 valence electrons. Now, to make sure that this is the final structure, we're going to check the formal charges on these atoms. So we'll start with the fluorine. The fluorine has, so all these fluorines are the same, so we're only going to do it for one of them. So the fluorine, to work out the formal charge, you get the valency of fluorine, which is 7, minus the number of electrons that belong to it in this Lewis structure. So we've got 1, 2, 3, 4, 5, 6, 7. So the formal charge of all of the fluorines in this molecule is 0. Now let's consider the sulfur. The sulfur has a valency of 6, and the number of electrons that belong to it in this structure is 1, 2, 3, 4, 5, 6. So the sulfur in this structure also has a formal charge of 0. So all the atoms here have a formal charge of 0, and so that's telling us that this is the final correct Lewis structure. Now, you notice that this molecule does not satisfy the octet rule because the sulfur in its valence shell has 2, 4, 6, 8, 10, 12 electrons altogether in its valence shell. That's more than an octet. But that's okay because sulfur is in row 3, and elements in row 3 and higher have available d orbitals that can accept extra electrons. So we can have it's okay to have an expanded valence shell if you're in row 3 or up, like sulfur is. Remember, this formal charges method is a more sophisticated and a more realistic theory than the octet rule. So this structure is correct.